Okay, welcome everybody. My name is Jonah Hobson. I'm coming to you from Woodland, Washington today, and you're finding yourself at the Showcase webinar series. Today, we got a great session featuring Joe Kuzar, ITI Assistant Technical Director. Title is Bull Rigging, Who, What, Where, Why, and How. A lot of questions in there, but we hope to answer all of them today. So just briefly before we get into the real reason that you guys are here, the meat of the presentation, and turn it over to Joe, just a briefing on ITI, who we are. Apologize if this you've heard this before or some version of this, but for new folks, it's a good idea to give them some background. So you can see it right there, clear, the why of ITI. We exist to serve and learn every day. That's kind of our guiding principle here. We find ourselves doing something that isn't really connected to that or can't be tied back to that. Got to reassess and figure out, well, why are we doing this? So it's something that drives each and every employee here at ITI, and hopefully we pass that on to our customers and partners and everybody that we interact with. Very briefly, we're proud of this. We work with these companies as well as countless others that aren't listed, unfortunately. But we're very proud that these leaders look to us, and we have a small part, as small as it may be, in the success of their company as a whole. It's something we pride ourselves on, and we're really proud to work with the best across different industries. Just want to highlight this very briefly. If you haven't heard of kind of our newest offering, ITI VR, we're really proud of this as well. Definitely check out iti.com/VR to learn more. But VR, crane and equipment training simulators. So we have different crane types in there. Really the most immersive way you can do operator training, hands-on practical training, assessments, potentially even qualifications without being on an actual machine. So check it out, learn more about it. If you have questions, please let us know. So today, your presenter is Joe Kuzar. I mentioned he's our Assistant Technical Director here at ITI. Been with the company since 2012. He's got a hand in writing, refreshing all of our curriculum. You can see he's been in the industry for years, tons of experience in the construction field, as well as safety, and he volunteers for the industry and sits on the ASME P30.1 committee, as well as the CCO Lift Director committee. So great to have Joe with us today. And just the last thing before I turn it over to him, your little control panel might look a little bit different. I think I grabbed an old picture. But if you do have questions, we want to address them, we want to answer them. We'll leave time at the end for that. So please just use that question pane you see there, submit them. I'll be collecting them. And then at the end, I'll feed them over the air to Joe, and hopefully we can get an answer for you. So no matter what it is, at what point in the presentation, go ahead and submit those, and we'll go from there. So without further ado, I'm going to turn things over to Joe and let us get into the meat of this presentation.
Well, welcome everybody. I hope this broadcast finds you well. And today's topic is basically, what is bull rigging? It's even from our perspective, it's something in recent years more and more clients are asking for. Bull rigging is a method of basically, bull rigging is a method of rigging that doesn't use conventional means such as mobile cranes or overhead cranes because they can't gain access to the area. Bull rigging often involves manual load handling techniques and taking into consideration the environment that the lift is being done with. So what are some of those situations that create the environment where conventional methods aren't adequate or possible? Well, the first one is we don't have any overhead access typically. So we see this in the nuclear industry, in power plants, petrochem, things of that nature. There's just no way to get a hook over the work. We got to work around the structure and the process piping, et cetera. So we don't have any overhead access. Next is we don't have any crane access. You know, it goes right along with the first topic. where we don't have the overhead access, so we can't get the cranes in there to use it. Thirdly, our travel path is limited or restricted. So we don't have access to a proper travel path. And then we may even get into situations where the floor loading is minimal. So even to bring something like a smaller crane, like a carry deck or an industrial crane into the area to supply the hook, maybe the floor loading or access to get the crane to that level isn't possible. So those are some of the reasons that would cause the environment not to be conducive to conventional means. Therefore, we have to rely on bull rigging. So some of the common equipment that we see in bull rigging, on the next slide here, we talk about the different types of slings that we use. We've got a couple here just pictured that are most common, and we could probably add synthetic rope in some situations. But the first one over here, we've got wire rope, we've got alloy chain slings. All the regulations listed in the ASME B30.9 still apply to this. So we still got to use them properly, as according to the applicable federal regulations, whether general industry or construction, and then also the applicable ASME standards. So we've got wire rope, we've got alloy chain, we've got synthetic web up here, and then we've got synthetic web down below, my apologies, and then polyester round slings or synthetic round slings up above here with number 4. So we've got our different types of slings. And like I said, we could probably add synthetic rope slings to those. Probably out of the 6 types of slings spoken to in ASME B30.9, metal mesh would probably be the least likely to be used in a bull rigging environment. Next, we've got our hardware. Yeah, sorry, I skipped a slide there. We've got our hardware. So with the hardware that we have available to us, we've got master links over here. I'll just put a number 1 next to master links, oblong, pear-shaped, round. We've got shackles that we use, whether they be screw pin or bolt and nut style shackles. We've got our shouldered eye bolts. If you remember, for lifting, shouldered eye bolts are better than non-shouldered eye bolts because we can load them angularly. But if we want to move away from eye bolts altogether, whether shouldered or non-shouldered, swivel hoist rings give us, if they're applied properly, torque to the appropriate value if required by the manufacturer, and then full contact of the bushing to the body of the load. We got a swivel hoist ring that gives you 100% of its capacity as long as you have free rotation of the bail, of the bushing 360 degrees, and the bail 180 degrees. And then finally, we have our rigging blocks down below. These can be used to increase line pull, multi-part line systems. They could be used to help redirect force if we're using winches and tuggers and things of that nature to help move the load. Next, we have probably what most people think of when we talk about bull rigging is come-alongs and chain hoists. Thing to keep in mind here is they both fall under 2 different ASME standards. So ASME B30.16 is for underhung hoist, which would be manually powered or air powered or electric. And then we have lever hoist under ASME B30.21, which would be what most of us think of as our come-alongs. You're not going to find any information in any of the federal regulations regarding chain hoist and come-alongs in either 1910-184 or 1926-251. The vast majority of our information on the use of, inspection of, application of overhead hoists or lever hoist is going to be found in ASME or manufacturer literature provided from the manufacturer. We also have winches, which is ASME B30.7, probably the closest thing that we're going to get to using a powered lifting source, if you will, is going to be a winch. This, in conjunction with rigging blocks, helps move the load for us. We got to pay attention. Not all hoists are created equal. Some do not allow for vertical lifting or overhead lifting. They're specifically meant for horizontal load movements, where others are designed for overhead lifting. Just pay attention when you're making your purchase which one you're buying. And then at the bottom here, we also have what they call a grip hoist, also, often referred to as Turfer, one of the leading manufacturers. But that's another means and method of applying power to the system other than manual. But this one, you do have to operate the lever on the chain or on the grip hoist body to actually move the load. Another method for bull rigging, and some people don't really think about it this way, but we're still in a manual load movement activity, are jacks and industrial skates. Primary resource here is going to be ASME B30.1, jacks, industrial rollers, air casters, and hydraulic gantries. In the first image here, we've got hydraulic bottle jacks. That's one method. In the square here, we have mechanical jacks. And like I said, both of these are spoken to in the ASME B30.1. We also cover different lifting systems, kind of put it in a triangle here, but that would be like a Stearman system. Now, all of these have capacities that we have to abide by. All of them have manufacturer recommendations and prohibitions that we also have to abide by. And then finally here in the final circle, we've got our Hillman rollers. All of them have pros and cons depending upon what environment you're operating in. We also have beam clamps on our next slide here, different types of beam clamps. The important thing with beam clamps is they're going to fall under ASME B30.20, which is below the hook lifting devices. Not all beam clamps are created equal. We're going to find that out later on in the program, where some of these are meant for just vertical lifting only. Others will give you a little bit of room, maybe 15 degrees from vertical in either direction, where others are going to give you 360 degrees. So you got to pay attention to what the limitations are of the beam clamp that you select and what your operation is going to be. As we go through this, one of the key points that we're going to hit on numerous times is the importance of planning the load handling activity. Even though it's manual bull rigging, planning is important, staging the equipment, having the right equipment, and knowing how to use it. So what are some bull rigging applications that we have? Well, the first one here we're going to talk about is jacking and rolling. Simply jacking a load onto industrial skates, moving it through a facility. Some things we're going to have to be concerned about. Well, let's talk about the resources that are available to us first. So some resources that we may have when we're doing jacking and rolling, of which we've already talked about. Number one would be that ASME, and these are going to be all ASME documents, but B30.1, which is jacks, industrial rollers, air casters, and telescoping gantry systems. Those are all going to fall under ASME B30.1. So if this is your method of bull rigging, great resource for you. Sometimes we get the load up on industrial rollers and we're going to move it using winches. So we'll have to rely on ASME B30.7 for the appropriate use of winches. We still got to connect the load to the winches and get, things of that nature. So some other ones that may come into play are going to be B30.9 for slings and B30.26 for our rigging hardware. So those are some of the resources. Some of the equipment we may use, some of the equipment that we might use for jacking and rolling the operation. One, we're going to have blocking and cribbing. And we've got some great resources here at ITI. We actually have a horizontal rigging reference card that talks about the attributes of different types of blocking and cribbing, how to stack it. And I have some slides built in here to show you some of the panels of that card, but they even talk about the shear forces and what the different types of blocking and cribbing can support. So a great resource. We talked about another piece of equipment would be jacks, and with the jacks, you've got the hydraulic or the mechanical. Hydraulic, there's a little bit, I would call it a force multiplier in there that you can use. And I'm sorry, I'm typing industrial and I meant to type mechanical. But the one problem that you have with hydraulic jacks are if you're using two jacks to raise one side of the load, and we'll get into that in a little bit, it's hard to get two people in sync with either raising the load or lowering it by how much pressure they have applied. So what a lot of folks will do is they'll use mechanical jacks because the teeth on the mechanical jacks is incremental. So it's easy as people are communicating through the use of the mechanical jacks, you can count off and be like, okay, and lift, and everybody raises it, that increment of whatever those teeth are on those jacks, and lift, and then they go another one. A little bit harder to coordinate the jacks with the hydraulic systems, unless you have some sort of a manifold system where everything gets plumbed back through a manifold and controlled by one operator. We'll talk about the use of industrial rollers. Industrial rollers, you know, we get the load up. Some are, you know, the Stearman rollers are typically a little bit larger wheeled, better on rougher surfaces, where the Hillmans are smaller diameter, almost like little tank tracks, but they're good on smoother surfaces and going up over, actually climbing like maybe a slight difference in height between one plate to the next because of their construction. And then finally, we've already talked about possibly using winches as part of this process. So that's some of the equipment we may see in a jacking and rolling operation. But we have to talk about what considerations do we have when we do jacking and rolling. So some of the considerations that we may have, and I apologize, I can't write and type at the same time, or write and speak at the same time I start writing what I'm saying instead of what I mean to write. So some of the considerations we have with jacking and rolling, we got to consider the weight of the load. We got to consider the weight of the load. Once we do that, we've also got to consider the share of load to each. Having a little technical difficulty here. We got to consider the share of load to each of the supporting industrial rollers that we're putting it in. So, you know, the same tenets of rigging, what's it weigh, where is the center of gravity, and then that helps us determine the share of load. Because these skates, just like slings and shackles and other types of rigging hardware, they also have capacities, and we have to ensure that we don't exceed the capacity of our industrial skates and rollers. So knowing the share of load based upon the distance the industrial rollers are from the center of gravity is very important for us. We got to make sure that the area is prepped properly. You can imagine maybe you have a winch in the system. You've got the load up on industrial rollers. You're moving it along. Everything's going perfect, but because we didn't put a push broom on the surface that we were moving the load, now there's a rock, a pebble, maybe a nut, something laying on the floor that gets hung up under the rollers, and now everything comes to a grinding halt, and it overloads the winch and could possibly overload the rigging. So we got to make sure the area is prepped. That is key to using these, particularly if you use air casters. Any kind of cracks in the surface, usually we tape those up with duct tape or the aluminum tape that they use for ducts and HVAC systems to seal that floor up so the air casters can get the appropriate pressure and lift and move the load. We got to consider inclines and declines, because if we're going up a hill or up an incline, more force is going to be required to move the load. If we're going down a decline, we got to have enough back force to basically hold the load back so it doesn't run away on us. And all of this also comes into play with what we call the coefficient of friction. You know, a load on wheels, typically a very generalized number that we like to use is 5% or 0.05 times the weight of the load will give us the, for lack of a better phrase, the effective weight that we're moving. But that changes based upon like air caster systems. I think if I remember correctly, most of them tout coefficient of friction of like 0.002. So you're like at 0.2%. So you can take a relatively heavy load, put it on air casters, and push it with your finger. We have load nests here in Woodland, Washington that we use during our master rigger programs. All said and told, probably weigh about 16,000 pounds. A student with the load on air casters, a student can push that load with their finger. if everything is dialed in right and all the pressures are right. But there's a lot of prep and a lot of planning to get there. Other considerations when we talk about jacking and rolling, and I've already mentioned this, we've got to consider the capacity of our equipment. Is it going to be able to support the share of load that we're expecting? A big one, communication. We got to be able to communicate. We talked about this up front, that this is manual load moving, which means people are going to be right there in close proximity to the load, the travel path, the rigging. So we definitely have to be able to communicate. We don't want to get a load moving too quick for us to handle and somebody's in the travel path or at a pinch point. So communicating, planning is so key to what we're about to do. And with that communication, we can add in, we got to consider personnel placement. And we've got to consider the plan. What is our plan? If we don't have a plan, what do we really have? I just read a signature line on somebody's email, and it was like, without planning, all we have is a wish. I think it's a good statement. So planning is key to this. And once again, all of our people are in close proximity to this. So we want to have absolute control of the situation. We want it planned out. We want it communicated. Everybody should know what's going on. On the next slide here, these are just some of the panels off of that horizontal rigging reference card that I mentioned, and some of the things that we talk about in there that are, kind of just reiterating some of the considerations I've already mentioned. Like the very first bullet point here speaks to the fact that, has a plan been developed and discussed with all the affected personnel? So planned and discussed, that's your communication and your planning component right there. We've got to understand the importance of the load's weight and its center of gravity, which drives the share of load to each industrial roller. We got to make sure we heed all the manufacturer's instructions, prohibitions, recommendations on use. Before doing any jacking operations, we got to ensure that the opposite end or side of the load is stabilized. We don't want to start coming up with the load and then the other side gives, or the blocking rolls. If our cribbing pile is too high, it could possibly roll the load. We should probably have some sort of friction material between the jack load point and the load surface. Metal on metal has a lower co-friction of metal on wood. So inserting wood blocking, we use plywood shims. Sometimes you can get little pieces of rubber that increase that coefficient of friction, so you don't have that slippage that we're concerned with. Another thing about communicating, and this could be handled during a pre-job brief, is we don't ever want to leave the load unattended while supported by the jacks. That's a live load. We think about unattended loads and suspended loads when we're talking about the use of cranes, but it also applies even here in bull rigging activities. If the load is being supported by our rigging equipment, it is a suspended load technically, and we have to ensure that it's safed off and that it's landed. There's no, almost think about lockout, tagout, stored energy. That load up on that jacks, there's a lot of potential energy there, and if it shifts, it could come down. To help prevent any accidental jack engagement or disengagement, we always recommend that you remove the jack handles from the jacks, whether they be mechanical or hydraulic. People could trip over them. They could accidentally bump the levers and engage the jack or disengage the jack. So just removing them so it prevents that. And that's spoken to in ASME B30.1 as a practice, if you will, a best practice. Mechanical jacks, we want to ensure that the linkage engagement is achieved by the handle's full range of motion, so no partial movements. Everybody should be using one of those full clicks, and that's one of the advantages of those types of jacks. Next, we'll talk about jacking from a cribbing pile, as illustrated here. This is panel 7 of our horizontal rigging reference card, but we got to make sure that a column of cribbing material is aligned below the jack. That thing, it has to be fully supported throughout. You can see there's no voids, no air, if you will. It's fully supported from the base of the jack to the ground. We have to make sure that the jack's primary and auxiliary load points are fully engaged. One of the ways we do that is using some sort of material between the jack connection point and the bottom of the load, increasing the coefficient of friction so it reduces the chance of slippage. But also we want to make sure that the jack is fully engaged with the load at a point where the load also can support that weight, because now it's going to become concentrated on it. And then, as stated earlier, we got to make sure that the jack base is fully supported. We don't want the opportunity for this thing to teeter left, right, forward, backward. We want a nice, stable base. At the bottom of the card, we offer a reference which we should all heed with any rigging equipment we use, whether it's bull rigging or conventional rigging, but refer to the rigging equipment manufacturer's specs for proper applications and limitations. That should be part of any planning process and any use of any type of rigging. Know what the manufacturer's limitations are and how they want you to use their material. Another topic, continuing with jacking and rolling, some other things with rolling practices. So we've raised the load up, we've got it on jacks, we're placing our industrial rollers underneath. We've got to consider the share of load to the points. Make sure that we have appropriate calculated share of load, we're accurate, and that it's not exceeding the capacity of those rollers. You see here we've got a 3-point roller system compared to a 4-point roller system. And, you know, sometimes the discussion comes up, we believe that, well, you know, 4 is better than 3. Not necessarily with roller systems. If you will, just think about this. You're moving a piece through an industrial setting on a shop floor, but now on the shop floor, there's a floor drain and the concrete kind of slopes to it for drainage purposes. If you have a 4-point roller system and you're moving through there, when you hit that indentation or begin to hit that indentation, the skate closest to that has the possibility of kind of departing from the load and taking that exit ramp to that low point. That wouldn't happen with a 3-point system, because it's just like a tripod that you would set survey equipment up on in the field. You know, it's more stable. So we actually recommend, when possible, use the 3-point roller system versus a 4-point because of that. I had mentioned earlier, we got to consider removing grit and debris from the roller travel path. It will hang it up. It could overload the system very quickly. It could damage equipment also. Steering persons only steer. They're never pulling. They're never part of the, they're not part of the motor that's making the load go. They're simply there to steer it. And we want to keep palms down, face down, to avoid any hand crushing. Let's just say if our hands were underneath the steering industrial roller and something happened where that handle got slapped to the ground, if our hands are underneath, our hands are going to be crushed by the handle. That's why we want to have our palms facing down above the handle. So if something strikes the steering mechanism, it removes it from our hand instead of pinning our hand. And then we got to make sure we have enough people to push or pull the load. Once again, considering inclines, declines, and things of that nature. Moving on to another type of bull rigging activity involves winching. When we get into winching, things we'll talk about here on the next slide, we talk about resources that are available to us. Well, one key one is B30.7, which speaks particularly to the winch system. So we got the B30.7, and then we've got the other cast of characters. We got B30.9 for our slings, B30.26 to our rigging hardware to connect the load to the slings. And then we could also have B30.1, where we're putting the load up on industrial rollers and using jacks and things of that nature. So those are some of the resources. Some of the considerations we have when we're doing jacking or doing winching activities. We've got to consider line pull. You know, how strong is the winch that we're using? Did we calculate it properly?
Just real briefly, sorry to interrupt, Joe. I'm going to jump in. A couple of questions came in, and it applies kind of to everybody. We had one. I just want to confirm the presentation file as well as the recording of this session will be made available to everybody following the webinar, and we'll send that out. And also, I know Joe is referencing a lot of different ASME standards. We have all of these available in our bookstore. We can provide a list to everybody of everything we touched on here, as well as links directly to those products at the ITI bookstore. So there'll be some follow-ups after this, and yeah, don't worry about writing every single thing down. If you're taking notes or anything like that, we'll get those resources out to you.
All right, fantastic. Yep. Thank you. So some of the considerations for winching, we talked about line pull. How much capacity does our winch have? Do we have to put rigging blocks in the system to multi-part our line? So line pull is definitely a consideration. We talked about the inclines, declines, and calculating the amount of force required to move the load or hold it back if we're going down a decline. So that's part of our planning process. We've got to consider how to anchor the winch. You know, it's not just going to sit there and look pretty. We've got to be able to anchor it to something, and whatever we're anchoring it to has got to be able to withstand the forces that are going to be applied in our system. We may have block and fair lead loading to consider, where now we're talking about not just the load on the rigging block, but as that load is applied to maybe a column that we are using to help secure our rigging block to guide the winch line through. So block and fair lead loading comes into play. And we may have to contact a structural engineer about the facility we're in to ensure that the structure itself can support these forces, which would be, you know, I'll put down structural competency here, if you will, just an abbreviation. Once again, load weight still comes into consideration, probably should be near the top of the list. And then our coefficient of friction also comes into play. Each of these jacks and rollers, each of these industrial rollers have their own coefficient of friction. That's in the manufacturer's literature. So that may even be a part of your selection when you're purchasing the equipment. Obviously, if we get ones with lower coefficients of friction, probably anticipate that they're more expensive, but they're also going to require less force to move the load. On the next panel here, we have the winching. This is also off of our horizontal rigging reference card. We spoke to those coefficients of frictions. These are averages, but they definitely play in. So a load on air, I mentioned air casters, 0.002. A load on rollers, or a load on wheels, if you will, 0.05. Once again, averages. You're going to get more specific information once you talk to the manufacturer of whatever you're looking at. Different formulas here for moving a load on a level surface, uphill or downhill. So a lot of good information just on this panel here for jacking and rolling. The next topic or method of bull rigging is going to be drifting. This is what most of us think about when we hear the phrase bull rigging. We think about chain hoists and come-alongs moving a load. You'll hear people refer to it as Tarzaning the load through a facility. These are things we have our own bull rigging course that we do. We also do a little bit of bull rigging in our master rigger course. Students really enjoy that from an instructor's perspective, and it's amazing. They can spend most of an hour planning that load movement and then less than 5 minutes executing it. So if you do proper planning, good things happen, and the execution goes without incident. So some of the resources that we're going to look at when we talk about drifting, some of the resources we're going to have are going to be B30.9 for the slings, B30.26 for the hardware. We're going to have B30.7. We could actually use a winch system in a drifting activity to power the load movement. It is possible. Remember, make sure you have the right winch though. Is it able to do vertical overhead lifting, or is it just for horizontal lifting? The big ones we got to think about though are ASME B30.16, which is our underhung hoists, whether manual or powered. And then we also have B30.21, which is our manually operated lever hoists or lever hoists. So those are some of the resources you can go back to find some information on the use of that equipment. The next, some of the considerations we have when we're drifting. Some considerations we got to consider the attention. We don't want to select the hardware based upon just share of load or the load weight, because angles are going to be involved in this. We definitely have to consider the amount of tension that we're applying to the system. We've also got to consider the structural capacity. We're going to be attaching these chain hoists or come-alongs, what have you, to the structure itself. Do we have a rated load point for doing this? We can't just assume that it's good enough or it looks nice. We think it'll good. Unfortunately, I've seen people try to attach chain hoist to process piping. Not a good idea. We've got to identify preferably an engineered lifting point. We have to know the capacity of what that thing will withstand. We may have to get engineering involved. If it's a facility where you, during outages, are constantly, I don't want to say constantly, but every outage, you're going to be in that area doing lifting, just do the analysis and put the capacity of it right there above at that lifting lug so we know what it is. With that, we've also got to be able to figure out the share of load, and we've got to be able we need to know the load weight. It all starts with that. Remember, the tenets of rigging, what's it weigh, where's the center of gravity, and what's our rigging method? And I apologize, folks, my pen stopped on me here. As soon as one decides to write, I'll get back to that, but I'll just go through my notes here. So when we're talking about, and I'll repeat myself for those of you taking notes on the other side of the screen here. So our considerations when drifting are: what's the tension? What's the structural capacity of our lifting point, like our engineered lifting lugs, so to speak, in the structure? What's our share of load and what's our load weight? Just some of the considerations we have to think about. Cautions about drifting. Best practice is the tension in the primary chain hoist is reduced when the load is drifted with a secondary chain hoist. At some point, that second chain hoist begins to accept some of the load from the primary chain hoist. That's a good thing, but at the same time, each chain hoist has to be able to support the entire weight of the load, because just as pictured here, that primary chain hoist is supporting the whole 2 tons of this load as it sits on the ground. The secondary chain hoist over here will eventually grab some of that as we move it along. But each chain hoist must be able to support the entire suspended load, as I discussed. And we never want to drift the load using 2 chain hoists on the same beam to the point that the horizontal angle is less than 30 degrees without a substantial engineering review. We recommend that you use, at this point, that you would use a trolley beam where there's no angular loading, there's no additional tension. Everything's more or less just vertical, so you don't have the additional tension. On the next slide here, they talk about, proper location of your secondary hoist. As you can see, based upon where you put it, the secondary chain hoist relative to the primary chain hoist, you could see increases of up to 26% additional loading just based upon the placement of that secondary hoist. So we have to be aware of that and cognizant. Once again, it's not anything we're going to be able to correct once we start the execution portion of our plan. This is in the planning phase where we consider all of this and our location. If we don't have a welded in lug or something we can use, maybe we're working around a lot of I-beams, we can use drifting. We can use beam clamps for lifting. We get into, for attachment points, excuse me, you get into these where you've got a 90-degree angle. Well, everything's just vertical. You're dealing with the weight of the load by itself, no additional tension. But here, you can go up to a maximum of 40. For this particular beam clamp, they're saying 45 degrees. We've got to be aware of that. We've got to and down below they show a picture here of 30 degrees. What's the limitations that the beam clamps offer? On the next slide, we're going to see that this particular one, it's allowing the end user to go up to 15 degrees from vertical, pretty much in any 360 degrees around that connection point, but only 15 degrees. So when you're selecting your beam clamps, be aware of what their limitations are. On the next beam clamp, on the next slide, this one here is giving us from vertical, we could go 90 degrees out from vertical if we have to, and it's telling we have 100% of the working load limit. And then looking on the side, so basically this particular clamp gives us our best range of motion, if you will, for connecting a chain hoist to. We don't have any limitations. Probably a little pricier than the other ones, but if that's the tool you need to do the job, then that's the tool you need. Talk a little bit about blocking. We got to set the load down on something and building proper cribbing stacks. So panel 4 of that horizontal rigging reference card that I've been referencing, ensure that the grounder floor is stable enough to support the cribbing or load weight. This is even good information if you ever get a flat tire along the road. I've seen in the past where people have tried to jack up a car to change a flat tire, and the shoulder of the road is sloped, it's soft ground, it's mud, and the jack just isn't supported by the surface and they can't get the car jacked up. Something as simple as that. We got to make sure the ground or the floor is stable and able to support the cribbing and the load weight. You could have these cribbing stacks here could possibly have a substantial amount of weight in and of themselves. That may be part of your calculation when determining floor load. We got to make sure that the blocking is of sufficient strength to prevent crushing, bending, or shear failure. There's actually a panel in the horizontal rigging reference card that gives you a generalized view of what those values are for different types of wood blocking. Considering the span between the blocking is able to carry the load. We recommend that when we build our cribbing, that the widest face is on the bottom. Best way to illustrate it is, if I can draw a box here, we don't want to put it like this. We would rather that box be placed like this, like the second one here on the ground, widest face down. So I'll just label these A and B. I love technology. When it's working, it's fantastic. But we definitely would be looking more at the B, the wide face sitting on the block of the wood.
I'll just jump in for a second. I know there are a lot of people on the line. Thank you for joining us. You'll notice a lot of these, the principles are familiar from other types of rigging applications when we're using a crane or other load handling equipment, but specific to bull rigging, and that's a difference. Joe mentioned a lot of these are touched on in different courses, master rigger, intermediate rigging that we have, but the bull rigging course specifically focuses on these areas. So I think Joe's back up and running here, so I'll turn it back to him.
Appreciate y'all's patience. So going back to our blocking conversation, inserting and blocking, insert or remove blocking or shims to minimize the fall distance in case of jack failure. We don't want keep the blocking as close to the bottom of the load as possible, so to minimize that distance if something were to happen. Shims and wedges can be used at the base or within the cribbing pile also to maintain perpendicularity and meet the predetermined height requirements. You can only jack a load up so far on a cribbing pile. I think it's 4% of the distance between your supporting points, and that's all spelled out in ASME B30.1 for us also. We recommend that we do full blocking on the base layers to reduce the loading pounds per square foot imposed on the surface. So if you can see here, even in our illustration, the very first layer is 100% blocked. We don't have any gaps, no air gaps, and that's to decrease the amount of bearing pressure on the ground surface or on the floor surface. We may need to contact a geotechnical engineer to ensure that adequate ground support is there to distribute the load. We may have to contact a structural engineer if we're inside a facility to ensure that our travel path will be able to support that, and that determines how much blocking and cribbing we need to do. And then also, when we're dealing with blocking, there is a required, what they recommend in ASME B30.1 is that the cribbing pile height should not recede 2 times the width. Simply stated, the higher we're going, the wider the base of the blocking pile needs to be. On the next slide, we talk about share of load, and just some things here, determining the share of load. It's not that you just simply divide this by 3. Share of load is going to be dependent upon the distance that the cribbing or the blocking piles or crib piles are from the center of gravity of the load. And just some simple things to point out, like here we've got a 3x2 base. Well, that 3x2 base ultimately is we've got about 83%. We're producing about 1,250 pounds of PSI or PSF, excuse me, in this example. Now on point B, and I'll change colors so it's easier to follow along. On point B, our cribbing stack is narrower. It's not 3x2, it's 2x2. So we've got a smaller footprint, and it's going to produce more ground bearing pressure. It's going to produce 1,875. Now those two, A and B, are supporting the load together on that side of the center of gravity. A and B are working independently or working together on that side, but on the opposite side, we have point C, which is a 4x4 base, and we can see here it's supporting that entire end, and it has to be able to, it's seeing 938 PSF, but what's helping it is it's a 4x4, 4 foot by 4 foot footprint of cribbing that's distributing the load. So just used for as an example on here, but once again, another panel out of our horizontal rigging reference card. The card is, I believe it's 3 or 4 years in existence, but a great card if this is what you're doing. I know I keep going back to that, but it is a tremendous resource in the planning process. So some other drifting concepts. So we talked about the equipment we talked about the resources available to us to determine how to use the equipment properly so far. We've talked about the different types of applications, jacking and rolling, winching, drifting. Now let's talk about some of the concepts that are present when we do bull rigging. The first thing is line pull. How much line pull do we need, or does our winch give us? Line pull is going to be based upon those parts of line that are supporting the load. So in this case, we've got, as I have in the blue circle here, all of those parts of line come across, and it looks like we've got 1, 2, 3, 4, 5 parts of line in this case to determine how many, the essential line pull back here. Not only do we have to consider line pull, but we also have to consider the loading on the beam. So in these situations here, we've got to consider beam loading too. On the other side, a little bit more of a complex situation, because the parts of line the parts of line to determine line pull are going to be these 4 right here. But when we're considering the parts of line to determine the low beam load, it's going to be based upon just these 3 parts. So we have to have a clear understanding of not just line pull, but also beam loading. And this is a great example of that. The next slide, we talk about share of load and tension. Some of the considerations we get here is what's the share of load at each of these points? Yeah, what's the share of load at each of these points? With that, we also have to consider the tension that's present. How much tension is here due to these angles? So we've got to think about tension also. With all of that into consideration, we've got to consider the beam loading up here that's taking place because of the shear load and the beam tension. And then finally, we've got to consider what's our equipment capacities, and I'll put that over here off to the side. So what's our equipment capacities too? Primarily based upon what's the tension that they're going to experience. When we get to the next slide, it's basically we're taking everything we just figured out, but now we got to do them for each load transfer. So as this thing comes across, we've got to consider all of these in each scenario as we move it across. What's the shear load? What's the beam loading? What's the tension? And does our equipment have the appropriate capacity as the load would move right to left? I mentioned that we could use winches in a bull rigging situation. Here we've got the same considerations. They're using 2 winches. Obviously, if we're moving it in this direction, winch A would pull the load as winch B pulls out. So going back to one of the very first things we talked about, good communication between the operators of both of those winches. You don't want them working opposite one another and pulling in opposite directions. So good communication, good coordination between those operators. But it is possible. But we still have to consider the beam loading. We have to consider the tensions that are applied. We have to consider the block and fair lead load due to the angles. Just put fair lead loading. And we've got to consider line pull. And how many parts of line do we need to be able to successfully pull this off based upon the equipment that we have? So those are just some of the concepts that are at play with any of these bull rigging scenarios or applications, and they all have to be addressed, preferably in the planning phase. If we address everything in the planning phase, that's our practice time, the planning phase for this. You hear athletes talk about the mental preparation and mental reps that they get. That's what planning does for us. It gives us the mental reps. So when we go out and execute, we've already thought about the contingencies and everything that could happen, and we've planned for it. So planning is very much key in bull rigging. We don't want to get in a mindset where because there's no machinery involved, we just go out and do it because it's manual. People can get seriously hurt if they don't plan properly. As it says here, when you mess with the bull, sometimes you get the horns, a little turn on rodeos, but bull rigging gone bad. So what are some things that we might see? And this is more like hazard recognition, but some obvious stuff. And I'm going to highlight here the areas that are concerning to us. Right up here, if that's showing up okay on the screen in the green arrow, we've got, or in the green shaded area, what they've done with that hook is they've gone through and hooked the hoist chain of the chain hoist back on itself. That's prohibited by ASME B30.16 and ASME B30.21. And if you read the manufacturer's literature, they also prohibit the practice. On the next one, there's actually quite a few things here to consider on the next one. My first question is, well, what's it connected to? Will it support the load? We've got to consider here that they've also choked back on the hoist chain itself. Looking at the chain condition, it looks a little bit rusty and not well taken care of. We got to think about the share of load between the connection points on the pipe. So a number of things that we can consider just in that section. On the next slide, once again, choked back on itself right here. And then we may not have inline loading here. It looks like the housing, if you will, of the chain hoist is actually bound up against the structure. That's not good. That goes against ASME B30.16 and 21, and also manufacturer recommendations. Some other considerations that we should be looking for: sling protection. We're using, it looks like a synthetic web sling to secure the chain hoist to the structure. Do we have any proper sling protection as that thing goes around the I-beam? And then once again, in that orientation, the load is rigged, choked, the hoist chain is choked back on itself, which is a prohibited practice. Another photo coming up here. You know, look at how they're taking the hook. If you can see this, they're actually taking the hook and just tip loading it, just connecting it to the metal structure there. That's not acceptable. So improper use of the hook right here, and then we also have it occurring on the back side. So these are things we should be looking for when we get out. If our folks are doing this, I would highly recommend that we stop the operation, explain to them what we're doing and why we're doing it, and then move on. Another illustration here talking about improper use of the shackle. They have a choker hitch formed with a shackle on this web sling. The problem is the pin is riding on the body of the sling, which it has the potential now to back out. So that shackle actually needs to be flipped around. On this end, the shackle in the foreground of the picture, they're side loading the shackle just the way it's oriented on the sling. But also you got some bunching and pinching that you've got to be concerned with there too. So to avoid all of those poor practices, if you will, you know, bottom line is good training and good practice leads to successful outcomes, and that's really what it's about. We've got to put people in we got to play to our folks' strength. We got to put them in positions to succeed, and we got to give them the knowledge to do the job right. You know, our workforce, there's attrition due to retirement, and we've got a lot of great folks coming into our industry. We got to take care of them, but we do have to train them properly so they can take care of business and provide for their families and help support and grow our industry. But it all starts with the investment in those people and providing them with the knowledge they need. You know, the way we approach the training aspect is the first thing we look for is we want them to have an understanding of the theories and principles that are at play. We're not going to beat them up in the classroom with the information. We're going to give them what they need to know and understand it. We always tell folks, we want you to be in a defendable position. Whether you choose to do something or choose not to do something, you need to be able to defend that choice. And the only way you can do that with is knowledge and understanding these theories and these principles. But we go a step further than that. We also want to have them take those theories and principles that they learned in the classroom sessions and now go and apply it in a hands-on environment and do skills building activities. That's where, with the adult learner, that the information really begins to make sense to them. Classroom stuff is great. It lays the foundation. But when they get to apply those theories and principles and basically assess what they've learned and put it to use, that's what really seats the knowledge and really provides impactful training that sticks with the guys when they leave the training environment and go back to work in the field. Through that process, we reinforce the safe and efficient practices. You know, training is, yes, it's about doing it safely, but from my time in safety, I've found that you can have a safe work environment successfully coexist with an efficient work environment. It all comes back to the planning, though, planning and training of our people. But ultimately, we want to create a positive safety culture within an organization, starting with some of these principles and theories that we talk about. We want folks to take that knowledge and, you know, spread the word and do it safely. We want everybody to go home at the end of the day with all their fingers and toes. So I appreciate your time. I believe we're going to be opening it up to questions, but I thank you for your time and look forward to hearing from you.
Thanks, Joe. Awesome stuff as usual. We do have a couple questions. Like Joe said, thanks for your time, taking some time out of your day. We're all very busy, I know, but important stuff we're touching on and getting specific on some of these topics and really digging in. It's only going to help everybody in the industry if you're connected, whether you're executing bull rigging tasks or you oversee people who do, or if you didn't know anything about them even, and you didn't know when and where to use it. So that was the ultimate goal of today's session. But let me jump in here really quick. We got a couple good questions. So Chris asks, and this is, I believe, came up when we started getting into the drifting section. He asked if there are any specific advantages in using a grip hoist winch versus a typical come along.
A grip hoist winch, I mean, you have the potential to stand off a little. The problem with come alongs is you are right there. You've got the lever on the lever hoist, or the come along, if you will. Your operator is right there, very up close and personal with the rigging, all that tension. A grip hoist, yes, they still have to operate the lever, but they can stand off ever so slightly. And stay out, just get out of the fray, so to speak, and still provide the movement. As with anything, make sure that they're properly trained in the use of that, the grip hoist, what it can do, what it can't do. That's the important part. If it's something new to your organization, please take the time to do the appropriate training with them so they understand how to inspect it, how to use it, how to apply it.
Awesome. Okay, just a couple more. So Rudy asks, you touched on a number of ASME standards that are applicable not only to bull rigging, but other load handling applications and practices. But is bull rigging or rigging with chain hoist specifically called out by OSHA or any other regulatory body?
Not really. I mean, 1910-184, which is material handling for general industry, it was originally promulgated in 1975 and last updated in 2011, really doesn't mention anything specifically about bull rigging. 1926-251 was originally promulgated in 1979 for material handling and construction activities. It was recently updated in 2012, and once again, no real reference to bull rigging, chain hoist, come-alongs, etc. Maybe some very vague, generic references to just the equipment as a general statement. But your primary resources are going to be the ASME documents, B30.16, B30.21. B30.7, 9, and 26. So those are going to be your best avenues, and the manufacturer of the equipment. What do they say? Think about it. They designed it, they engineered it, and they built it. They know what it's capable of doing and what it's not capable of doing. So don't overlook information from the manufacturer.
Okay, good question. Thanks, Rudy. I think we'll probably end with this one. Zane asks if ITI can develop best practices that can be written into his company's load handling manual. Good question, Zane. I'll just touch on that briefly before turning it over to Joe, but that is a service that ITI offers through our field services group or division, but we do load handling manual review, as well as building from scratch and working with each individual employer and company and kind of setting standards that are uniform across different sites, countries even, but for the whole organization. But if Joe, if you want to expand on that. Yeah, manual development is definitely something we offer as one of the field services through our technical services group. We can do manual review, start from there, sometimes even an audit to find out what issues, or an audit can help prioritize what you may need to correct and help drive the manual development. But we've done that for quite a few Fortune 100 companies, from site specific to inclusively across the corporation for no matter what they do. So it is definitely a service that we offer. Okay. So we want to respect everybody's time. Again, thank you for joining us today. As I mentioned before, we'll make this recording available to all, as well as the presentation file. So just want to say thank you one more time. Appreciate you guys investing in yourselves and in your teams, and really just looking to grow your knowledge in this area. So we'll be back with the next version of the Showcase webinar series in the future. Don't have anything on the schedule just yet, but look out for those announcements. And again, thank you. Just remember out there, there's no substitute for doing it right. All right, everybody have a good day.